look at reflections. So there's certain things we want to look at for reflections. Does it preserve orientation? Does it have symmetry? And then we're going to look at equations for vertical lines. Equations for horizontal lines. Equations for the x-axis. Equations for y-axis. We're going to do y equals x, y equals negative x, and reflection notation. Okay, so first of all, does it preserve orientation? So let's try one of these. We're going to look right here. We're going to perform this transformation. We're going to reflect over, let's do the x-axis first. We're going to reflect this shape. Oops, not sure why it's only doing one line at a time. Let's undo that. Let's try this again. Do a line of reflection. We're going to choose the line. We're going to use this one. We're going to choose the shape. We're going to apply. There we go. So if we look, we've got C, A, B. So I'm just going to label these. I'm going to label each point. This one is C prime. This point, B prime. And this one, way down here, because it's the furthest away from that line, so this point is A prime. So let's talk about what happened. They're the same shape, but if we look, my orientation has changed. Okay, A needs to be the furthest away, still is the furthest away. B, C, they have to be the same distance from my line of reflection, which in this case is the x-axis. So if I look right here, does it preserve orientation? No, it's the few ones that actually don't. Does it preserve asymmetry? Is it asymmetric? Yes. Okay, when we do equations for vertical lines, we're going to use x equals. Okay, these vertical lines right here where they cross the x-axis, we call that x equals. Equations for horizontal lines are going to be y equals. Equations for the x-axis. It seems opposite, but it's not. We're going to talk about y equals 0. If we look right here, that x-axis, y is always 0 no matter what x is. So it's y equals 0. And this formula goes from x comma y. When we flip it over the y-axis, we get x comma negative y. Let's see if that's true, looking right here. This point right here, B, is over 1, 2, 3, 4, 5, 6, up 2. And if we look at B prime, we're over 6, down 2. So that works perfectly, just like this equation does. The equation for the y-axis, I'm going to just space these out a little bit. The equation for the y-axis is actually x equals 0. And its formula is x comma y goes to, once it's performed, it goes negative x comma y, where the y stays the same, but the x changes. So let's try this out if we were going to reflect this over it. So I am just going to delete all this and all these points. So let's say we were going to move this across here. Now if I look for C, I'm 1, 2, 3, 4 away. So if I stay there, 1, 2, 3, 4, I think that is going to be my C prime. Let's see if it actually moves there. A is 1, 2, 3, 4, 5, 6 away. So I've got to stay on that line and go 1, 2, 3, 4, 5, 6. So this is my spot here, and we'll label that. This is going to be A prime. And then we've got B, which is the same amount over here. And we're going to label that B prime. And we're going to see then if it goes and ends up in that exact same place. So let's do our actual transformation. We're going to choose a reflection. We're going to choose this line here. We're going to choose this object, and we're going to apply it. Look, it fell perfectly into its space, so that worked great. Next, we're going to talk about y equals x, okay? This formula is going to be, we're going to go from x comma y, and we're going to go to y comma x. So they're going to be flipped. So if we look real quick, let's undo this. And we're going to draw in, we'll just draw in the line as well. Ooh. So we're going to draw in that line. So we construct, choose a line, and we're going to go like this. We want it y equals x. That's that line right there. Now we're simply going to do a transformation where we do a reflection. We're choosing this line right here. Oop. Choosing this line to reflect this object. We're going to apply. And it flips. So those are just reflected across that line. Just changed just slightly. Okay. And then if we reflect across y equals negative x, we go instead of x comma y, it moves to negative y, negative x. And it doesn't really mean negative, it means opposite. Okay, so those are my different reflection formulas and rotations. So these four, let me space this out a little bit. These four formulas right here, equation for the x-axis, we go from x comma y to x negative y, xy to negative xy, xy to yx, y equals negative x goes from xy to negative y negative x. Those are the ones that are important. The rest you can just count when it's from a specific line.